Oh boy, this is going to be fun. We're going to simplify a complex fraction. And you have to admit, this looks like it's kind of a complex fraction, doesn't it? Well, I have some good news for you. It's not nearly as complex as it looks. One little secret here is this line right here, it doesn't mean anything other than just divided by. That's all it means. It just means that this thing right here is being divided by this thing right here. That's all that we're saying. And if that's the case, this should really not be that bad at all. So let's go ahead and try. I'm going to rewrite the top fraction, and you should too. And then, instead of rewriting this bar, I'm just going to use a divided by symbol. And then I'm going to rewrite this fraction. Now, in the past, I told you guys that if you see something like 8 minus x, maybe we might rewrite that. I don't know if we need to just yet, but we'll consider. We might be able to factor out a -1 from there. But for now, I'll just leave it. I don't know that I have a good reason for that. Okay, now the divided by we'll go ahead and convert. We can now rewrite this guy like such. I'm going to factor the top here. It's 3x plus 5. And again, if you don't know that, this is something you need to practice. It's called the difference of squares. Please go and Google it, find some practice problems. This guy in the bottom will x factor. And this turns out it's a perfect square, this x squared minus 16x plus 64. I would hope that you guys would recognize that means that it's x minus 8 times x minus 8. And again, just like the difference of squares, man, it would make your life so much easier if you recognize this pattern. And one way to do that is to look at a bunch of practice problems. The concept here is called perfect square trinomial. If you Google that, you will see bunches of problems that you can practice and then nail this down, get it done quick. We're going to change this divided by to a times, and when we do that, we'll flip this over. We'll make it so that there's an 8 minus x on top, and we'll make it so there's a 3x plus 5 on the bottom. And again, we'll put in our implied parentheses because there are implied parentheses around the top here and around the bottom here. And that means that this is really all just one big fraction. So even though it says multiply, it might as well just be one big fraction. And they're all being multiplied. Now, since we have common factors in the numerator and the denominator, we can cancel. This 3x plus 5 looks exactly like this 3x plus 5. So we're going to go ahead and cancel. And that'll leave us with 1 here and 1 there. And this 8 minus x does not look exactly like this x minus 8. These two look similar, but not exactly the same. So there's not much we can do just yet. So I'm going to go ahead and rewrite that. It'll be equals 3x minus 5. And then this 8 minus x, I'm going to rewrite as -1 times x minus 8. And then we'll write all of that over x minus 8 times x minus 8. And now I can go ahead and cancel this x minus 8 with either of these x minus 8s. And when I do, I get a 1 here and I get a 1 here. And you'll notice that I'm left with -1. In a previous example, I showed you how you could cancel 8 minus x and x minus 8 and just leave a -1 on top. And this is just another way of doing the same thing. Now that I have 3x minus 5 times -1, I'm going to move that -1 out in front just because I like it. It looks prettier and neater to me. So we will go ahead and say this is negative 3x minus 5 all over x minus 8. And I could actually, make it so that it's a -1 times 3x minus 5 like that if I wanted to. Or I could just do this. I can just leave that negative sign out in front of this fraction, and let me go ahead and get rid of that. Let's get rid of that negative sign. and we'll put it right there so it's really neat and clean. This is a negative 3x minus 5 over x minus 8. Now again, we're going to pretend like what would have happened if this was a function, if it was f of x. I'm going to ask you guys the question, is the domain all real numbers? What's the domain for this function? And again, what you'll say is, well, the domain is all real numbers except for, and you can pause the video and see if you can figure it out yourself. And then I'll tell you in a second. The domain here should be all real numbers except for x should not equal positive 8. If it does, the denominator becomes 0 and this whole thing's undefined. All right, so there's an example of simplifying complex fractions for you. It really wasn't that bad, was it? You really just have to change the divide to multiply, and then it gets real easy. Oh, and change this big old fraction bar into a divided by sign.